Hey everyone, welcome to another YouTube video. And in this video, I'll be talking about what is Lambda and Kappa architecture in data engineering. So there are many YouTube videos regarding the same topic, and it is one of the most frequently asked questions in system design interviews for data engineers. So all these other videos addresses about the definitions and what is the comparisons between these two types of architecture. In this video, I'll give you an intuitive example on what is Lambda and Kappa architecture. And I guarantee you that this one video is enough for you to learn about what is Lambda and Kappa architecture in depth. And you will never forget what this architecture will help you and how you can apply it in your software engineering project. So without any further ado, let's jump right in. So I'm not going to start with the Lambda and Kappa architecture definitions and what is the difference between these two and what is the pros and cons of them. So simply, I'm just going to start with an example. Let's say you're working on a social media app at a startup. Initially, the design would be something like this. You will have a mobile app, and then you will have your database. So you're developing a social media application, and all your users' data will be collected in a database right over here. So whenever a new user installs a mobile app, or in case if a user logs into his mobile application, then the write request will be sent to your database. And suppose your team management or the business leaders in your company wants to know how many concurrent users or like how many active users were available in a single day, you would just run a query uh, seeking the distinct number of active users with an interval of 1 day. And through this query, you will be able to identify the number of daily active users by querying simply your database. So this is a very simple design, and initially this would be fine to go with. But if your mobile application, that is, if your social media application goes viral and it starts to scale to millions of users, then your mobile application writing to a single database won't be feasible at all because there are only so many number of concurrent write requests that can happen in a single database. Your first option would be is to scale your database. You can try both vertical scaling and then horizontal scaling by sharding your databases, and then you can receive your write requests. But that can be done for a particular point of time. You can't keep on scaling your database. So the next level of design would be is to use a messaging queue such as Kafka or Kinesis to collect this real-time data from your mobile application. And then this batch layer will write to your DB. So that design would look something like this. Just copy this because one delete this middle layer. The search queue. Since your mobile app is scaling, it will be multiple mobile apps by multiple users. You'll be sending it to a message queue. So we can consider this message queue as something like Kafka or Kinesis. You're familiar with this example. And then before writing into your database, since there are millions of records that you get every day, you need to process these records in a batch like format. And your regular database won't be able to parallelly process so much number of records. So you can have processing layer, which should usually be a map reduce job. If you work with Hadoop, you would know what I'm talking about. If you're not familiar with Hadoop also, then it's okay. So MapReduce is basically a big data processing technology. It is in the Hadoop ecosystem. So a MapReduce job actually processes your data in a distributed fashion. More about that on another video. You just have to understand MapReduce is a distributed processing framework. That much is enough for the scope of this video. So this processing layer will count the number of distinct users that are logging in your mobile application. And usually a MapReduce job, which scales to millions of records, will take typically 5 to 6 hours. And once the data is ready, then it is being written into your database. From your database, you simply have to just query the end result for that day. And then you could tell your business leaders that like 2 million users have logged in today, 2 million active users have logged in Friday. Saturday, there were like 4 million users, like that. So this message queue and processing layer, since this MapReduce job takes about 5 to 6 hours, you can consider it as a batch processing layer. So this is known as the batch layer. So this architecture is fine, but let me give you a scenario. You're running this batch process every day at midnight, and it takes around typically 5 to 6 hours for the job to complete. And if you have like way too much active users in a particular day, the ideal time would be like 7 to 8 hours. So if you start your job at midnight, then you'll get your end results by 8 to 8:30. That is when you're starting the day. So what if you want to like do it in real time? So every day at 8 or 8:30 a.m., you would know the number of active users that were yesterday, right? What if at 12 p.m. Or at 2 p.m., a business management guy comes to you and asks, like, I want to know the number of active users right now, or you could give me like the number of active users in a particular window, like from 1 p.m. to 2 p.m. In such a case, you won't be able to deliver that requirement because your processing layer, that is your batch processing layer, your map reduce job will take several hours for the end result to come. In order to address those types of requirements, you would need a real-time data processing layer or a real layer. In Lambda architecture, we call this layer as real layer or speed layer. So in this type of design, we would add another component. So this will be a real-time layer. I just have to connect this message. So this real-time processing layer can be Apache Spark framework or Storm, which is currently popular. And just add over here. Reduce. So in our existing software project, we have added another layer, that is the real-time processing layer. So this reads the same messages from the messaging queue and processes the data in real time and then sends it into your DB. So you may wonder, since this map reduce job and real-time processing layer are doing the same activity, then why can't we just eliminate this once we have added real-time processing? The thing is, that is a good question, but there will be so many bottlenecks when you are having a pure real-time processing layer. It is recommended to have both layers uh, in order uh, to get accurate results. And like when you're scaling a real-time infrastructure, you would have many design constraints. We'll look into that. So just remember that if you are using a purely real-time system, then you have a lot of design considerations to be done before removing a batch layer. And there's one more thing in real-time processing. If you're looking for accurate results, then uh, the memory would be very high for processing data up to the point with more accuracy. So in such case, we have systems like hyperlog which will give you a probable answer. Like for example, if you want to know the number of active users in a day from 1 to 2 p.m., then using real-time processing and hyperlog, you could get an approximate number on the number of active users. Hyperlog is like out of scope for this video. But if you're interested, you could go through the Wikipedia article, which is very nice. It covers in depth on what this algorithm means and how it works. So through this example, this is what a Lambda architecture is. Lambda architecture will have a batch layer and a speed layer or real-time layer. And then finally, you will have a serving layer as well. So when will you have a serving layer? So you will have a serving layer when you want to run more analytics. Like for example, we are just we are just trying to get the results of the number of active users in a day or in a particular time window, right? But as your product matures, you would need much more dashboard analytics. In such a case, you would need another layer, that is the serving layer. Let me show you what I mean by that. So instead of only one database, there will be multiple databases. And then you will be having dashboard analytics. So what I mean by dashboard analytics is like visualization tools like Tableau, etc. So as your product matures, you would have dashboard analytics, and you'll have multiple data analysts or data scientists that will work with the end product of your data to get more results, more data driven results from whatever data processing that you're generating. So this would be your serving layer. Entire thing is databases and dashboard analytics. You know, your serving layer. Okay. You have your processing layer, that is your batch processing layer. You have your speed layer, and you have your serving layer. Let me just go to the presentation. Like that. So see, these are the major components of Lambda architecture, which I just explained in my example. I don't have to go through that again. Kappa architecture is basically a real-time only architecture, where you will have only your real-time speed layer and your serving layer. So through that one example, I'm covering both Lambda and Kappa architecture, and I hope this example was intuitive enough so that whenever someone asks you what is the difference between Lambda and Kappa architecture, how would you apply that in your data engineering project, you will be able to explain them with ease. And finally, I would just like to give a gist about the challenges of Kappa real-time only architecture. So real-time only architecture sounds very fancy, that whatever data that you are generating in real time, you will be able to perform your analytics and apply processing logic over it. So it is a very, I would say, it is a good architecture, but you have to have a lot of initial good design practices to get the maximum out of a Kappa architecture. So these are the major or general challenges when you have a only real-time type of architecture. The first one is data volume and unbounded memory requirements. So in batch processing, you would have a defined memory for processing, and that processing will take place on defined data that is generated over time. So unbounded memory requirements, what I mean by that is that if you're, in our example, it was a social media app, right? So on one particular day, you are getting like 1,000 active users, 1,000 new users on, like, once your app goes viral, and the same app is getting like 10,000 to 20,000 new users every day. In such a case, your real-time system should be able to handle those unbounded memory requirements. The next one is architecture complexity and infrastructure monitoring. As since your real-time system should be auto-scalable to meet demands, you have to have proper infrastructure management policies and proper infrastructure monitoring, so that your system remains available most of the time, and you will be able to identify faults and predict them even before they arise. And the next one is keeping up with the dynamic nature of streaming data. That is the same like the first point, that is unbounded memory requirements. So you should know when users will use your app, when more number of active users will be using your app, and when is the slowdown time for your app, like a particular segment of your users will be using your app in the evening more than they are doing in the morning. So you should be able to track down using analytics and scale your real-time systems accordingly. And the next one is handling back pressure. So what do I mean by back pressure is that, like, if there are thousands records that you are getting at a particular time when you're processing it, and you're writing that final result into a NoSQL database or in an analytics dashboard, then this NoSQL database or relational database or analytics dashboard should be able to handle data of such volume. So back pressure means that if you have uh, real-time data, if the speed of your real-time data is way more than your NoSQL or relational databases handle, then there will be a slowdown, obviously, and there will be a lag time, and you should be able to have systems that can handle such lags, and then ensure that uh, your final downstream users, that is your databases, are able to handle the right requests of such huge volume of real-time data. And finally, query processing or data streams. So there might be some limitations in querying over real-time data when compared with batch processing, and you should go through which queries would work for real-time processing and what are the special use cases in windowing real-time streams and how you can query unbounded data. So in this video, I'll leave some links on uh, how to properly design a pure real-time data architecture, and I'll uh, uh, leave this slide and design that example that I gave as well in my GitHub account. I hope this video was helpful for you guys in learning what is the key difference between these two architectures, and hopefully it will be useful in designing your own data engineering projects, or like when in an interview, when you're faced with this type of questions, you'll be able to answer them adequately. So if you like more videos related to system design with respect to data engineering, then do consider subscribing to my channel. And thank you guys. Catch you in the next one.